Question 3. So, kuthiwa lana a ball of mass 0.5 kilograms is projected vertically downwards. Ukusho ukuthi la iyajijelwa iya phansi. Yabo? From a height of 1.8 meters. Ukusho ukuthi isuka from a height of 1.8 meters iyajijelwa lento iya phansi leli bhola leli with an initial velocity of 2 meters per second. The ball hits the ground and bounces 2 times. Okusho ukuthi afithi nje nali ibhilidi elithize. Lo muntu lo uphosa ibhola eliya phansi ku 1.8 meters ibhilidi lonke. So uliphosa ngevelocity initial ka 2 meters per second. Leli bhola liyehla fike libhambe, phinde libhambe kuyimalima. Uyayibona lento le. Yonke yenzekile ke le. Sebethini? The ball hits the ground and bounces 2 times. Okay, sikufundile. The position time graph for the motion of the ball from the instant it is projected. Ngenkathi nje idedelwa phansi until futhi ayidedelwanga le ijijeliwe. Ngobani iqala ngevelocity ya 2 until it hits the ground after the second bounce. Okusho ukuthi emotion yayo yonke le ifike ijijelwe ibambe mesiyama yona yonke emotion le mase kwathiwa ignore the effects of friction because bazo affecta any ama calculations ethu. So this is a diagram. As you can see ku 0 seconds isuke i1.8 ezelijijela kodwa kwenzakala ngi distance. Yabo? As isikhathi sinyuka i distance yenza njani? Iyehla i distance between the ground and ini ngoba uyabona ukuthi ku 0 seconds isuke ilapha, but as isikhathi sihamba which means khona la yini la ama bounces. Yabo? Ama bounce akhoza ini the shape to be altered, otherwise bizoyiqalela nje la ihambele kanje. Yabo? Njengale part le yodwa, but ifike ibhambe kwenzeke something, ibhambe kwenzeke something, and the contact time while it is in contact with the ground kuni impulse eyenzakalayo lapho. But again asikayabuzi, sikafunda imibuzo, sikayenza lutho, asambe siyobheka kumbuzo wokuqala. Alright, so write down the maximum vertical height reached by the ball after the second bounce. Okusho ukuthi emva kokuthi leli ball elibhambe kosibili linyuka amamitha amangakanani phezu kwalazo bilibhamba khona, phezu kwalowo mgaqo ke lo o leo flow le o leo origin le. Alright, so the second bounce nuts ila. Yabo? So the time you bump it starts book 1.3 la kodwa liyepi ku 1.8, and so now you're getting the difference. So that maximum vertical height is going to be equals to 1.8. 1 mark nje lo subtract 1.8 minus 1.3. Yabo? 1.8 meters minus 1.3 meters usinikeza 0.5 meters. So this is the vertical distance enjani reached by the ball after the second bounce. Yabo? After the second bounce. Njengoba ubona ithemba bounce ukuthi yabo? So si extract information nje the difference ngithi second bounce nansi, first bounce nansi. Okusho ukuthi the difference between 1.3 no 1.8 is the maximum vertical height reached after the second bounce. Okusho ukuthi 0.5 meter noma halfway meter elilodwa I distance eyigqumile leli bhola isigquma kosibili. Uyayizwa into le bayichaze kanjalo, and kuyibala for 1 mark it is just ini lo minus lo uthola answer yakho. Asengumbuzo landela. Okay, nangu question 2 olandela for 4 marks. Kuthiwa lana the ball strikes the ground with a speed of 6.27 meters per second and is in contact with the ground for 0.2 seconds during the first bounce. So when he calculates the time uthi 1. Bafuna ndana isikhathi Sizosibala kanjani ke lesikhathi sethu? We know uVF lo. Now uVI now bathe u2. So VF is equal to VI plus 2A delta T. Le equation nje ejwayelekile yokuqala. Maningi amanye ngawasebenzisa, but as long as uzokwazi ukufinyelela kwi-answer, I usually take the simplest one enganawo or ngijawaza ama equations of motion. Ukhona la wabonayo ukuthi uzoyithola i-answer but ngale equation uzoyithola kalula kunale. So that's the one I usually pick. Alright, so angithi mina up is positive. Okusho ukuthi ama velocities omabili azoba negative. Why? It was thrown downwards. It was projected downwards. Okusho ukuthi negative 6.27 lo is equals to negative 2 plus 2. Acceleration there it is always downwards, negative 9.8, and then for delta t. So kuzoba negative 6.27 is equal to minus 2 minus 19.6 delta t. Certain number like terms here. Minus 6.27 ayingali plus 2 is equal to minus 19.6 delta t. So kuzoba minus 6.27 minus plus 2. Osinikeza minus 4.27 is equal to minus 19.6 delta t. Uma sesila so divide ngo minus 19.6 indawo zo 2. Ukuze isikhathi sethu vele kumele sibe positive. So sihamba kahle. Delta t is equals to 4.27 divided by 19.6. Sithola bani lapha? 0.22. Yaba? Isikhathi sethu leso ubani? 0.2. But isona siphi isikhathi leso? Usamele senze njani? Sisimultiply ngo2 lesikhathi lesi. Sisimultiply ngo2 ukuze sizokwazi ukuthola bani? 0.44 seconds. Uma sisimultiply ngo2, why? Remember kune rebound. It strikes back and comes back, angithi? And then mesizokwenza njani? Izo bounce for the second time. So sizomultiply ngo2 lesisikhathi and get 0.44 seconds. As any isikhathi sethu T1. Asini kumbuzo olandelayo. Alright, kuthiwa manje determine the velocity with which the ball leaves the ground after the first bounce. The time ishaya phela ngo minus 6 sesiyazi ukuthi uVF minus 6.27 owala. Uyayizwela, but the time isizosuka isuka ku 0.9 iposition angithi isuka ngasiphi speed. Lapho sizosebenzisa equation ethi VF squared is equal to VI squared plus 2A delta 1. It is given kephi kwi data sheet yakho. So sifuna bani ke thina ke? Sifuna VI, and this will be 0. So 0 is equal to VI squared plus 2 into minus 9.8, and then y wethu 0.9 lo. Qala bona. So mayanga lelo minus VI squared is equals to mase ufaka yonke lento inje bi calculate. So 2 times minus 9.8 times 0.9 minus 17.64 lo. And then we divide on negative ndawo zo2 kuzoba positive 17.64. Uyazi ke ukuze sikhiphe usquare kuzomela sifake isquare root on both sides. So VI is equals to the square root of 17.64 4.2 lo meters per second. Yona ini velocity. So labo 4 marks nje be projectile motion izinto ezilula. Ucaphuna khona la. Uyazi the time ibhamba initial velocity ezosuka ngayo iyona esifunayo. I-final nje obvious kuzoba u0 ngobani ila izojika khona iphinde ibuye izobhamba nje. Yayizwe into le. Alright, so which means ubani u4.2 meters per second. Yini initial velocity le yakuphi? After the first bounce. Okusho ukuthi la awuthi ngibhale ngokhala ohlukile. La initial velocity yethu yala ubani u4.2 meters per second. kodwa efika ngayo la u6,27 and then eqala ngayo ivelocity uba u2 meters per second. Eqala ngayo ngibhalela nje ukuthi mina ngikhumbule kwi-diagram indlela engiyisebenzisayo leyo ukuthi ngikhumbule izinto engizoyidinga later. So now if you can write it anywhere, even kuyona i-diagram, it's fine. Ayikho inking. La uzokwazi ukubhala khona, uzokwazi ukureference amase ucabanga mhlambe you need something ozoyibuka oseke wayibala noma oseke watshelwa. Mina I always use i-diagram because it contains yonke into engiyidingayo. So for 4 marks simphendulele ukuthi i-velocity ezosuka ngayo after the first bounce leli bhola izokuba sasebenzisa i-equations of motion. Why sisebenzisa i-equation of motion? Sinama conditional 2 asasivumela ukuthi siwasebenzisa ama-equations of motion. Number 1, it has to have constant acceleration. Siyazi kuthiwa ignore i-friction angithi. So therefore mayehla it is yehla in free fall. So therefore it is only traveling by 9.8 meters per second squared as the acceleration yakho. And then number 2, it has to travel in one dimensional plane. Okusho ukuthi either ihambe ngo-x iye ka left noma ka right uzokwazi ukusebenzisa ama-equations of motion, or iye up and down uzokwazi ukusebenzisa ama-equations of motion. In this case uyabona nje ibhola liya down and up, down and up. So it permits us to use ama-equations of motion. Sayisebenzisa ke le. Why siyikhethile? It is because sinayilo, and the only thing we don't have ile nto abasibuze yona okusho ukuthi iyona equation le esivumelayo ukuthi sikwazi ukuthola i-answer yethu as 4.2 meters per second. Asengibuzo olandelayo. Alright, so sebethi manje calculate the magnitude usize lo uthi ngakanani, the magnitude of the force exerted by the ground on the ball during the first bounce. The first bounce after i-bounce yokuqala ifika ngoba ngo-6.27 angithi iphuma ngoba ngo-4.2 meters per second. Kanti simbala manje kodwa ihlala how many seconds? Basitshelile kwi-statement ukuthi ihlala 0.2 seconds. So we use le impulse momentum theory. Izothi F net noma siqale nje la, it's F net delta t is equal to the change in momentum. Okusho ukuthi F net is equal to the rate of change of any momentum. Yabo? Okusho ukuthi it is m delta v all over delta t. So F net lo uzobani m vf minus vi all over isikhathi asubstitute imass yethu nansi ku 0.5 kg basitshelile 0.5. I-final velocity, remember after the first bounce i-final u4.2, i-initially u6.27. but ke let us check i-direction yethu ke. Let's check i-direction yethu asithi up is positive. Up is positive. Okusho ukuthi le efika ngayo izobe i-negative. So le initial izobe injani? I-negative. Okusho ukuthi izoba no-negative. Le enyuka ngayo izobe i-positive. And then yonke lento sizoyi-divide ngani? Ngo-0.2. And then i-answer yethu as a force. So siyifaka yonke lento we-calculate. Izoba u-0.5 multiplied by 4.2 minus negative 6.27 divided by 0.2. Sithola la 26.175, but still round off to 2 decimal places angithi okusho ukuthi kuzoba 26.18 newtons as i-force yethu le abasibuza yona. Asenginombuzo olandelayo. Alright, so kuthiwa manje draw a velocity time graph. for the motion of the ball from the time that it is projected la ijijelwa khona iya phansi to the time it rebounds. So la ijijelwa khona iya phansi nala isibuya khona kuphela to a height of 0.9. Clearly show the following. So kumele senze the time taken when the ball hits the ground. Siyasazi leso sikhathi ukuthi u-0.44 kodwa kuzoba khona no plus no 0.2 seconds okuncane igap la kwi contact time yani ye flow neball. And then the velocity of the ball when it hits the ground. The velocity of the ball when it hits the ground ubani 6.27 meters per second. The velocity of the ball when it rebounds off the ground mase ibuya 4.2 meters per second oya upwards. So kuthiwa asidwebe i-graph. So I'll remove this graph ngala ukuze sodweba le graph abayifunayo because we don't need le ephume nabo asisayidingi. We have everything we need la ngezansi because angitsakhumbula bengibhala every time sithola something. So sidweba ini manje i-velocity time graph. I-velocity time graph yethu. Okay, and what we know is u2 la sithi nje la lo 6.27 sizothi for le yethu sothi down is positive la. So and then sibe no sithi u0.44 lo and then kubo 0.64 lo engiyaseduza kakhulu ukude njalo ngubekela kanje. So ubalo ngubhale ngo-orange u2 lo u6.27 lo u0.44 plus lo 0.2 be contact time kuzophuma u0.64 yabo. So kuzokwenzeka ke la lo uyanyuka esuka la ku2 eze la yabo. And then mase kwenzakalani ke mase la le part nje le kuzokwenzeka ini i-contact time and then mase qala la uzobe sesuka kubani ke yasithi nje la ubani u-negative 4.2 meters per second uzobe sesuka kuyena kephi la eseyapi lapha ya asimbeke nje kahle eseya nje la and then uzobe ubani ke manje siyazi ukuthi la isuka khona la manje isiziye la ubani 4.2. So we could draw mhlambe i-dotted line yakhona nakhona siyazi ukuthi negative 4.2 bathe the time taken when the ball hits the ground nangu 0.44. The velocity of the ball when it hits the ground ishaya ngobani ngo-6.27. The velocity of the ball when it rebounds off the ground isuka ngo-4.2. So asilendisheni. So singavala la sithi this is the time in seconds and then ngala i-velocity in meters per second. And then lapho usuwenze njani usuyidwebile lini i-velocity time graph yakho according to la stipulations abakunikeze yona. And then this marks the end of the question, question 3. Sesiqedile now, lesizobonana kwi-question elandelayo.